I'm delighted to welcome you to today's session in the Skills and Learning track. Marianne Bellotti, author of Kill It With Fire, has kindly agreed to join us today and talk about only topics that she's probably best to cover herself. So without further ado, I will leave Marianne to introduce herself and we can get the session going. If you have any questions as we go through, because everybody's joined on mute, if you can use chat, as is the case for all of the other sessions, that would be fantastic. If there's anything crops up in the interim that looks like it's of interest or concern or that's worth interrupting Marianne for, I will do that. Otherwise, we'll get questions at the end. So without further ado, Marianne, thank you for joining us. It's all yours.
Thank you for having me. It's going to be a great thrill to kind of talk to with you guys about like some of the stuff that I've learned throughout my career and compare experiences. So in Louisville, like brief introduction, I tend to refer to myself kind of jokingly as a relapsed anthropologist because all of my formal education is actually in anthropology, but my father was a computer programmer. So growing up, I was constantly surrounded by computers at a time when that wasn't really common. And so I learned how to program as a teenager for like my own purposes. I just sort of kept it going as a hobby. And then maybe about 15, as long as 20 years ago even, I started to do that more and more professionally and kind of jumped over to the career in software. And a lot of my career has actually been on super, super old systems. I spent about close to 4 years with an organization called United States Digital Service, which if you're familiar with the UK government digital service is a similar concept. We were basically a technical organization inside the White House that was going around kind of looking at old systems and trying to restore them to operational excellence. And prior to that, I was at the UN doing data pipelines, ticking like data stores from multiple organizations, a lot of nonprofits that didn't have a great budget for technology, and like trying to figure out how to integrate them and like make sure that the data flowed nicely and cleanly up to an aggregation point with the UN. Right now I'm back in the private sector, and I'm currently really working on this question of software safety in general and AI safety in particular in the defense and national security space. So that's a lot of work that's like a little bit different from what I've done before, but actually a lot of the same skills, a lot of the same approaches are still relevant. And that in a lot of ways, that's really what motivated me to write the book, Kill It With Fire, is that I felt like we kind of put modernization in this little niche, and a lot of software engineers that I work with, we go like, well, I'm never going to work on an old system, so I don't have to know anything about how to run a modernization project. Like, it's fine. I'll just work on like new things only. And the reality of it is that the skill sets that make people really successful at dealing with old systems and maintaining them and like iterating towards a more modern implementation are also the same skills that are really helpful in building new technology. And so broadly, the finer points of the book are that the things that make modernization projects really hard really aren't the technical problems. The technical problems are usually pretty straightforward and well understood. They may require long-term planning and a lot of like work just to get, you know, like lift this part here, move this part here, sort of coordination. But we know what we're looking at and we know roughly how to solve it most of the time. The really big problem in modernization efforts are people problems, like how organizations are structured, how budgets are done, how we incentivize people to behave within organizations. And there's a lot less talk and like knowledge sharing around those type of problems. So a lot of like, for the book is kind of classified as a computer science book, but I kind of always think about it as like a business book, because it's really about you have to get this thing done within the context of a particular organization, and how do you navigate that, and like what resources are available to you, and like how can you get more, right? One of the things I really love to emphasize when I'm talking with people about legacy technology and legacy systems is that legacy systems are successful systems. People are using these systems. They're getting utility out of the use of these systems. If they weren't, they would stop using them. And if they stopped using them, then they would be the easiest migration strategy in the world. We would just turn them off, right? The easiest modernization is one where you could just turn the system off. So it's really important to sort of come to it with that frame of mind. And I think talking to a bunch of mainframe practitioners, I actually don't need to sell you on that point. Like, you understand this from the get-go. These systems that you're working on, regardless of their age, they are highly successful, really critical systems. And to that end, the other thing I'd like to emphasize with people is that we tend to assume that newer technology and newer approaches are better, that we advance in this kind of linear way, and that each like methodology or approach or protocol that comes next is learning from the mistakes of the approach before and improving upon them. And I do not believe that's true. I think that technology kind of advances in cycles. It switches through the same paradigms over and over and over, and there's sort of a trend and more of a fad type behavior than there is necessarily a linear improvement. So I always like to push back on this idea of we're going to modernize this system simply because it's old, right? And kind of like approach it from a, what kind of utility are we trying to get out of improving this system? And like, just in general, I find that when you're working on projects like modernization projects, really because they tend to not be like 6 months projects, they tend to be like really long, substantial projects of like 2 years, 3 years, sometimes 5 years. When the plans start to get over 5 years, I'm kind of a little skeptical that we know what we're doing here, but still they take long periods of a sustained investment. I like to emphasize for people that what we really need to think about when we do the strategy of how we're going to approach this modernization and what we're going to do when, so we need to think about the incentives in the organization, and we need to think about how to build and maintain momentum and support behind this effort. So let's talk about old systems. One of the kind of pet peeves that I have when I go to people and I talk about legacy systems is that the first thing they say is, oh yeah, I've heard about the old mainframes that are in the banking system. I've heard about the old mainframes that are in the IRS. I've heard about like these horror stories about old mainframes. Is they very strongly equate legacy system with mainframes. I'm sure people have experienced this themselves. And the thing I like to emphasize for people is that legacy systems are everywhere. They're all different types of ages and flavors, and they involve all different types of technology, right? So I always give the example of like, there are web apps that were built in 2005 that are still in production. That's now over 15 years old, right? Like that is a legacy system. There's old Java middleware that is still running in production, causing problems. In fact, the vast majority of system failures that I was dealing with when I was going into organizations that had mainframes, it wasn't anything to do with the mainframe. It was the Java middleware that someone had put in between the mainframe and like whatever else the system needed to talk to. And then the third kind of example that I like to give people is something that people don't think about very often in a more open source friendly software world, is that there's actually a long history of proprietary software being used in enterprise organizations. And a lot of those companies, like not all of them have survived, but their software remains in production. And there's not always a really nice one-to-one equivalent to like migrate over to, because when the software company goes down, it is usually because the market for that particular piece of software wasn't large enough to support a sustainable business. So generally speaking, you don't have oh, well, we can just move this over to this exact same product from another company or from an open source committee or something like that. So that's another example of sort of legacy technology that frequently appears. And so the first question I want to kind of throw out to the people here and like kind of use the chat to sort of, add your thoughts is what's wrong with legacy systems? Like, why do we need to modernize them in the first place? What is some of feedback and the things that you've experienced that you think justifies this system being modernized? We'll give people a few minutes to chat and then we'll move on. Cool. Great. Right. So like here are some things that I find to be very common with legacy systems. And actually skills is not on this, but that's also a thing that I bring up quite frequently. So a lot of times when we're dealing with systems that need to be modernized, we're talking about their ability to maintain them, our ability to onboard people onto them. So we're looking at, there's either no documentation or the documentation is completely out of date and therefore useless. We're talking about technology that is past its end of life, not supported by its original vendor, has major security vulnerabilities on it because you're not upgraded in a while. And then the way more nuanced thing is like your underlying abstractions have changed, which means the assumptions that we were living under when we built the technology in the first place are no longer relevant. And as a result, every time we try to integrate this particular system with a newer system, we have to kind of like, there's no nice natural connection point between them. But I would say also that like a thing that comes up a lot with mainframes is people's endless panic about like all of the COBOL engineers dying or retiring, right? And like, of course, people conflate mainframes and COBOL really easily, and they're two separate issues. But the thing I tell people when they talk to me about the panic of like, well, all of the people that need to maintain this are like retiring, and the new engineers that are coming on the market don't have the skills, is that people have been saying that like there's hellfire and brimstone coming because all of our mainframe experts or our COBOL engineers are dying or retiring for like roughly 50 years that I know about, right? And like we still managed to train people and like maintain these systems. So it's an issue, and it's one that I look at when we talk about whether we want to rewrite a system in a different language or use a different approach. I kind of look at it as like a business decision. Like what amount of time and money do we have to invest in just the training of people to develop those skills versus the new technology? Are there skills that exist already where they will make this pathway easier? And so these are definitely things we think about. Okay. Big thing that I do when I'm working a lot with non-technical stakeholders who are always in the picture with legacy modernization is this attitude of like, just add computers. If we just add computers to this process, everything will be better. And I like to push back on that a lot, because what we have to remember when we think about systems in general and legacy systems in particular is that they don't begin or end with the computer or with the code. They are generally a combination of multiple computer systems. They also include analog processes, and because they include analog processes, they also include people. So you really have to try to look at the system as holistically as possible. What is the computer and the technology interacting with, and how does that affect the operations of the system? And the reason why this is relevant is, I'll give you an example. When I was working in government, we were looking at this particular process that involved data entry and tracking through Excel spreadsheets. It's a very common thing. And so my colleagues looked at this and they said, we know how we're going to fix this problem. We're going to put up a web form, and the data is then going to be tracked in a database, and it'll be way better. People won't have to worry about all of these Excel spreadsheets. And there are pros and cons to this approach, right? So the benefits of the Excel spreadsheets is that you have easier offline access when the network goes down. You have easier historical record. You can kind of just scroll up and scroll down on the spreadsheet, and you have an easier backup approach. Whereas with the web form, you have like the opposite end of that, right? Like now the backups need to be done via some IT requests to make sure you're doing regular backups. If everything goes down, people can no longer access the data. They can no longer like enter the data. And so these are kind of considerations. You don't just want to assume that putting technology in a particular process, it automatically makes things better. It really depends on the context. It really depends on like what sort of environmental variables are there, who's the user that's using it, and all of those kind of questions. And so I am very like, thing I emphasize for people is like the sum of its parts is not the thing we want to look at. It is not a situation if we just get the best, most impressive, most expensive, most modern parts, we now have the best system, because systems are ultimately governed by goals. And again, legacy systems are successful systems, and we want to come in respecting that. So we often forget that legacy systems are successful systems because in the course of trying to modernize them, we like end up quite often failing. And we usually don't touch systems that just kind of work. We only really look at these systems critically when like we're having trouble integrating with them with something, when they're not working fast enough for us, when there's something that like they're starting to, we're aware of them because there's something subpar going on. So we tend to overlook the fact that legacy systems are successful systems, but we shouldn't, because it's a really important thing to remember. Okay, so the first question I kind of start with when I'm doing legacy modernization is, have the goals changed since we created this program in the first place? One of my favorite things to do is to challenge the engineers that report up to me to design a system that does what this legacy system does, using only the technology that it was available at the time that it was designed. Because a lot of times, particularly younger engineers, they'll come into a legacy system, they'll look at the code and they'll go, this is awful. The person who built this must have been stupid, right? But when you challenge them to actually like, these are the pieces you have, these are the resources you have, go and design a system that fits the same requirements. 9 times out of 10, they come back like an hour later and they're like, it's just, I just was forced to do the same thing, right? It's the same system designed exactly the same way because I didn't realize that this product wasn't available and this service wasn't available and this language wasn't available and this thing hadn't been invented yet, right? So it's a really great exercise to do, particularly with younger software engineers, to get them to sort of be in the right headspace and appreciate it. In general, like older systems, we tend to assume that because they function, even if we're having trouble with them, we tend to assume that like all of the questions were answered in the development of the old system, all of the requirements were exposed, and therefore we can kind of do a one-to-one copy. We can sort of build the new system exactly the same as the old system and it will be fine. And the reality of it is we did not get everything right the first time. We just didn't necessarily expose all of the disadvantages to the first approach. And we're blind to the level of complexity on systems when they're set and they just work. And so we're not really seeing the correct level of work and detail when we're looking at a functioning system. So we want to like resist the temptation to just assume that the new system can just be modeled directly after the old system. And we really want to take the advantage of just like reinventing the wheel, right? How have users' expectations and needs changed? What would we build today if we were starting completely from scratch? And so here are some approaches I use to reason about systems in general. Like let's start off with this. How do we know that our needs have changed, right? So one way we know that our needs have changed is just straightforward user research. So here are some resources that I really like. Design exercises. And so Dropbox has a great mental model for designers framework that they use. I really love and like heavily cite the exercises from this group called Liberating Structures. Untools as well has a great set of design exercises. I just literally got like 3 whole like textbooks full of design exercises from various people in the design community, just like starting to get into the design thinking community and looking at the resources available there. It really does make a significant difference to sort of take people through an exercise that's designed to help them brainstorm, to help them communicate with each other, to help them find overlaps and needs and places where they contrast. You know, like these kind of approaches, they are often seen as like oh yeah, but let's fast forward to the implementation part. But when you do them, they provide a huge amount of insight into exactly what needs to be built and what the requirements should be. Okay, so the other question we have to ask ourselves is, how do we know that these improvements will like not make things worse? Like, how do we know they'll make things better? And the Excel example was one way of like a solution that could have possibly made things better, but in a different context could also have made things much worse because of the different realities of doing something on a web form versus having a file directly on a hard drive. this is another example that I really like that's really connected to the work that I do today in my career on AI safety. What I see a lot with a lot of our customers is that they have this sort of tiered analyst system, right? They're doing all sorts of like intelligence gathering, and they have like their first level analyst who's an 18-year-old kid who has a really, really terrible job of just that grunt data entry type work, right? Like they could be watching surveillance videos and like taking notes of what they see. They could be going through documents and like sorting them by category. They have a really just awful backbreaking set of data grunt type work. And then you have the tier above that with the more senior analysts that takes the data from the first tier and aggregates it and makes summaries of it. And then you have the tier above that, kind of the third tier of analysts, sometimes referred to as a supervisor, that aggregates all of the second tier analysts' insights and actually forms recommendations and conclusions about it. So the ask we usually get from our customer is that we want to replace the first tier analyst, this 18-year-old kid with this horrible job, with computer vision, right? We heard the AI can do this for us. We can just replace it with AI, right? And so the thing that I usually say to the customer that approaches us with this pitch is like, cool, where does your second tier analyst come from? How do you hire your second tier analysts, right? And they go, oh, well, so the second tier analysts are first tier analysts. They spend like a year or two doing that job, and we take the best people from that tier and we promote them to the second tier analysts. I'm like, great, where's your third tier analyst come from? And they go, well, that's the best of the second tier analysts. And I'm like, so if you remove all of your first tier analysts with AI, how do you train your second tier analysts? Like, who's the best of the best that you're promoting to second tier? And if that team tier is now weaker than it was before, who are your third tier analysts? And like, as soon as they say that, they kind of go, oh. And like, that's a thing that really we need to kind of think about when we're looking at how we're modifying systems, is how do people learn in this system? Like, what do their careers look like? How do they get promoted? Like, do they leave? Do they transfer? Like, what are their pathways through? And what sort of tools and approaches will speed up their learning versus just eliminating it? Broadly, this concept is referred to as the ironies of automation. It is a concept that has been observed since the early 80s, as far back as like sort of the mechanical automation of factories, that the way people build expertise is by doing operations within a system. And the more you automate that system, the more you take away the ability to develop those expertise. And so it's a thing you want to be aware of, because like sometimes it's not relevant, but a lot of times especially with systems like AI, it's super relevant that the human operator knows what the system is supposed to be doing, right? And so that we get to like now the technical strategy part of it, like what parts of the system is the change going to be the most valuable, right? Like, where is that change worthwhile? And the methodology that I really like for this is the ratio of coupling to complexity. And this is something that I borrowed a bit from the academic Charles Perrow, who wrote this huge, like it's like a Harry Potter size book about industry accidents called Normal Accidents. And his thesis in this book is that what creates a lot of these accidents that he was studying is the combination of a system being extremely tightly coupled and it also being very complex. So when we're talking about complex systems, we're talking about lots and lots of moving parts. And we're talking about coupled systems. We're talking about actions that trigger each other in a way that leaves very little room for you to stop the reaction. So the metaphor I use to explain coupling to people is kind of like, think of a row of dominoes. You hit the first domino and they're all going to fall, and you have very little time to sort of try to block the rest of the row of dominoes from falling. That's what you want to think of when you think of coupling. And I find that in general, most systems, there's a trade-off between these two, that you will never get to a perfect system that is loosely coupled and also simple, right? That if you decrease coupling, you tend to increase complexity and vice versa. And so one example of that, if you think about the very traditional, simple web server and database kind of interaction, and as you scale it up and you get more and more load and you have to figure out how to deal with all of this load, this tight coupling between this web server and this database, that if the database goes down, the web server automatically goes down, creates lots of problems. And the way we traditionally solve this problem is we go, all right, well, let's replicate it. Like, let's either have more data instances of the database. So if the database goes down, it doesn't take the web server down, or let's distribute the load across many web servers or something like that. And then what do we have to do in order to make that work? We have to add something, another moving part in between, a load balancer, a lookup table, something that routes all of those requests to now the duplicate instances. So that's a really great example of, we start off with a system that's probably too tightly coupled, and the solution to it is to add another moving part, therefore making the system more complex. So really important thing to understand about where we want to spend our coupling and where we're going to spend our complexity is that coupled systems that are coupled and probably should be coupled, or parts of systems that are coupled and probably should be coupled, are places where things are time bound. So an excellent example is like a chemical reaction. Like, you cannot stop a chemical reaction halfway through, right? Like, once it's there, and there's just nothing you can do. So time bound issues are, you're coupled, and no amount of complexity is probably going to stop that and be worthwhile. And then the other situation where we tend to see coupling, and that's the right solution, is when we're resource bound. So when we have limits on our people, limits on our hardware, limits on our money, these are all places where, like, it makes sense to be coupled, and we want to spend that part of the ratio there. Complex systems tend to be more fault tolerant, because the moving parts that you're adding are basically failovers and like things to handle load, and they tend to be easier to like right scale. You can kind of figure out exactly like how much load you want to have with them. And so this is places where complexity really pays dividends for us. So how do you think about that? Like, this is the problem that I think a lot of modern software engineering teams have, is that they have such resistance to this idea of building a monolith, and they have been indoctrinated into this idea that service-oriented architecture is better than a monolith architecture, and so you must start from a service-oriented architecture, otherwise you're building it wrong. And I spent a lot of time pushing back against this thought, because ultimately what you end up with is a whole bunch of services that no one is maintaining, and that no one can monitor, and that no one can like actually keep in working in production. And that's worse than having a monolith. So the thing that I gravitate towards when we're talking about, okay, how do we want this architecture to be structured? Where are we spending our coupling? Where are we spending our complexity? Is to remind people that coupling resource bound, right? And so what's a really easy resource for us to kind of negotiate a system around? It's generally people, because there might be some like disagreement about how much money we have. There might be some disagreement about how much resources we have, but there's generally not a huge disagreement about how many people we can spend to work on a specific project. That's not something, people don't just tend to disappear and appear randomly at a time. It's not like usually just a line item in a spreadsheet. Like, people generally know order of magnitude, how many people you have to spend on a particular project. And so what I say to people is that, like, for me, the minimum on a good stable on-call rotation is 6 people. That is the number of people that I need to run around the clock availability on a given service. So how many groups of 6 people do we have, right? And then we think about it in that way. We break it up on like what we have in groups of 6 people, and like, what does that look like? It's a little bit like Conway's Law, just a little bit more intentional in its thinking and approach. Okay, so if we sort of figured this all out, we know what our user needs are, we know how the system needs, where the real bang for the buck and system change are, and then now we have a good idea about like where we want to spend our complexity and our coupling. We have to form a plan of how we get there, right? And so we kind of look for the delta between the new state and the old state. And we sort of kind of try to determine what the subsystems of the legacy system actually are. In older systems, this can sometimes be rather difficult because they get very enmeshed with one another and their ownership is unclear. But it is really helpful to sort of get a feel for how we think about these systems in terms of subsystems, just so we communicate clearly about them. Sometimes you do have to do a hard cutoff. Sometimes it makes sense to do a hard cutoff, but I very strongly discourage people from doing that. Like, it's kind of a last option that I'll consider on the table, because it's almost always better to just gradually move traffic or load or capacity over between the old system and new system, so that you sort of make sure that things scale up the way you need them to, and that you don't have any unexpected surprises. So the last thing I want to talk about, and then we can kind of open it up for questions, is some stuff that I'm doing, that I'm working on right now. It's spending a lot of time thinking and writing and doing some research on what's called social graph theory. And it's sometimes called social network theory. I don't care for that term because people so quickly associate social network with like Facebook and Twitter and those sort of things, and it actually has nothing to do with any of that. I sometimes call it network theory, although sysadmins and network engineers get really annoyed at me for calling it that. But like, this is sort of the general set of terminology you hear when we're describing this type of thing. And the basic thing to understand about it is that it's the study of how information and behavior spreads among groups of people. And so the abstractions that are common in social graph theory are we have simple and we have complex contagions. So a contagion being a thing that is spreading between people across their personal networks. And so simple contagions are things like information, right? Gossip is really good. And complex contagions are things like behavior changes, things that require you to actually like do something or make a commitment or change a belief structure or something like that. And these types of contagions move across edges in between nodes in the network. And these edges are generally referred to as ties. And there are two types that they talk about in social graph theory: weak ties and strong ties. Weak ties would be like acquaintances, people you see in passing. Strong ties would be like family members, good friends, close colleagues, things like that. And then these nodes and these edges configure themselves into kind of structural formations that have names like bridges and hubs. I think hubs is easy for people to conceptualize. We all know that extroverted person that seems to know everybody and has all of these connections everywhere. Like, that's a hub in social graph theory. Bridges are multiple ties between two different groups of people. So kind of overlapping friendship patterns there, that's referred to as a bridge. And what I really like about this kind of stuff is that it gives us, it's often treated as like, oh, if we could only model things out with social graph theory, we could predict human behavior and then look at all the amazing things we could do with that. But I think that somewhat misses the point. What I find really interesting about social graph theory is that it gives us a language from which to talk about strategy and theory in a way that removes like personal bias from it, removes anecdotes and narratives, and makes it easier for people to compare and contrast different approaches and different perspectives. So give you an example. Let's say we have a situation, we're in an organization, we're trying to get our modernization work done. We know that we have to, I don't know, move this particular system to the cloud, for example. And we have this one particular supervisor that's like, nope, knock over my dead body. You will not make this change. Absolutely no amount of evidence, no amount of reasons, arguments is changing the supervisor's mind. They are a complete blocker. What do we do, right? Like, we want to escalate, we want to change this person's mind. Who do we escalate to? Do we escalate to the chief executive, to the executive, or do we escalate to one or multiple of the employees? Any thoughts? Give people a minute, because if you're like me, you always lose the Zoom chat and then you can't find it. What if they're all very shy? So let's talk about this for a little bit. Like first, if we're trying to change somebody's mind, we're trying to change their behavior. We're looking at a complex contagion. And what we know about complex contagions from social graph theory is that they spread best and easiest across strong ties and bridges, right? So we want situations where there are really close relationships, and we want situations where there are multiple really close relationships. So the question we want to ask ourselves is the supervisor, who does the supervisor spend the most time with? And who does the supervisor spend the least time with? And the answer should start to now become pretty clear. I always referred to this approach as escalating down. And before I started working in social graph theory, I couldn't really explain it in a way that felt objective. It was like purely instinctual and like kind of highly opinionated in its nature. Because what I tend to do in this kind of scenario is I find the most trusted direct reports of the supervisor, and I go to them and I appeal to them and I try to persuade them that what I want to do is the correct thing to do. And I try to use them to influence the supervisor up. Now, before I started kind of doing all this work in social graph theory, what I would say about this is that people are always more afraid to look stupid in front of their direct reports because people always feel like that imposter syndrome intensifies as you get into management roles, and you're always afraid that your engineers are going to make you look stupid. And so their opinions are way more persuasive to you than maybe your boss, because people tend to look at their boss and go, oh, he doesn't know what he's doing, or she doesn't know what he's doing, right? That was the way, that would normally be the way that I would talk about like why I tend to escalate down on these kind of scenarios rather than the traditional model of escalating up that most people go to. And like that's, you can see the sort of flaws in there. It's highly political. It's a little bit controversial to say like people are afraid of their direct reports and think their boss is an idiot. So they're going to be more influential if you go to the direct reports. It's a way easier way of like communicating clearly and like discussing strategy to say the ties are really strong between the manager and the direct reports. They spend a lot of time working together. And so the influence is greater. And then also because there are multiple direct reports, if we can flip two of them or all three of them, that we now have multiple like influences, we've now created a bridge. There are multiple connection points between the person whose behavior we want to change and like the behavior that we're trying to influence. A lot of you can also do it this way. You can also think about the direct supervisor's opinion and the direct report's opinion in tandem, because this is also a situation where you have the close ties between the person who's blocking us and their boss, and you have the close tie between the person who's blocking us and their direct report, and do kind of a combination. If these two people believe that the person whose opinion we're trying to change is like misguided and wrong, that person is likely to change their behavior. So you can also get that same multiple ties effect this way. A lot of my colleagues will do this, and then they burn a lot of bridges and they increase the barriers to the change they're trying to do, and they don't understand why. Like they'll go up to the boss, or they'll go up to the boss's boss, and they'll figure like, well, this person has lots of authority in the organization. And so this person will rain pain down upon this person and they will change their mind. But that's not generally the way people work, right? This person is very disconnected to the person whose opinion we want to change. And so this kind of approach really just breeds resentment more than anything else, and often sabotages things. So like just wrapping it up, and then we can open it up for questions. Some final thoughts. Legacy modernization is not about getting rid of mainframes. I'm kind of a mainframe fan. So like there are groups of people out in the world that understand like the value of mainframes. And success requires understanding and manipulating incentives. And I currently am finding social graph theory just really useful as a language for like getting everybody on the same playing field in terms of how we talk about strategy. And so thank you so much for inviting me to speak today. It's been a real pleasure. You can find me on most social networks under the handle Belmar. The book, if you're interested in the kind of concepts that I talked about and like reading my thoughts in more detail, the book Kill It With Fire is out now for No Starch Press. There's also an audiobook that people have a super fun time with. So I hope that you will like look me up on Twitter and engage in the conversation that I have on the internet about some of these concepts. And I'd love to take questions if you have any.
Brilliant. Thanks, Marianne. That was really fascinating. It kind of there's a number of things that sort of cropped up just listening from my own point of view to some of the things you were saying about the challenges. And we often approach these things purely at a technical level without understanding the social implications and the why and the I think that one of the things that really made me think was we were talking about the learning path and how automation can actually cause you problems at the same time as it actually making life easy for you. And as long as you clearly don't not do one because of the implications, but it's useful to understand that you are removing that learning path from more junior people who become the more senior people, but they have to go down a path to get there. So I thought that was really fascinating. We've had no questions so far.
Just because I'm just that good.
Exactly. It was all perfectly understandable and all very clear. So probably one of those things where people think about it later and then really start to
well,
think
like
about it.
Oh, sorry. Please go.
No, carry on.
I was just going to add that if people have questions after this session, they can always hit me up over Twitter, and I'm more than happy to like answer over Twitter.
Fascinating. Have you come to any conclusions around the sort of social networking? Because I think it's interesting to see, and I mean it's one of those things that often teams would benefit from seeing.
I wouldn't refer to it as conclusions necessarily. For me, what I'm working through now is how to really describe and go into that thesis of like, this is a language to talk about strategy in versus a modeling approach to predict people's behavior, which is generally the way people talk about it. I'm trying to figure out how to develop that argument out to be most effective. And there's probably another book in here, like just on this idea of like how we think about teams, how we think about organizations, and how we communicate with each other about why organizations are behaving the way they do using these kind of abstractions.
Yeah, and of course, as soon as you're dealing with people, you've got individuals' own sort of preferences, whether they're more extrovert or introvert, and other people talk.
Well, what got me on this was a comment made by a researcher about exactly that like people tend to gravitate towards this idea of personality types, right? And they want certain personality types because they think those personality types are going to be successful. So you can look at things like Myers-Briggs and like those kind of structures, and you can think of the framework of like introverts versus extroverts. And in a lot of the adjacent work to social graph theory, people will talk about like influencers, right? Like who are the influencers and like how do we do that? And like the comment that he made that sort of like hit me like a truck, which is always my favorite moments of inspiration, is he said that like people are paying attention to what the person looks like because people like thinking about people, right? And really what makes the difference is the position in the graph, right? It doesn't matter the characteristics of the person, it is their position in the graph that influences their behavior. And that it resonated with me because it described something that I had always said about engineering teams. I spent a lot of time working in government where we don't have the hiring pipeline of Google or Facebook or Amazon, where we have this infinite stream of brilliant software engineers that we can just pull from and like pick these dream teams. Like often I would walk into a government agency and I would not, like the bureaucracy around hiring did not give me a lot of options. I had to build the team that was going to do the modernization effort from whatever spare parts I could pick up. And I was not threatened by that because I believe very strongly that what makes a good software engineer successful is more about how they are resourced and the context that they're put in rather than their innate skills. And so I would take people that did not display themselves as like really amazing software engineers outside of the context of what we were working on, and I put them in an environment where they were enabled correctly and they do fantastic work. And so like that was something I knew from my experience. And to hear a researcher say it has nothing to do with your personal characteristics in terms of like personality type or even necessarily so much skill set, it's like where you are in the network and how you're positioned and how you're connected that's the difference maker. I was like, that's an interesting idea. And I want to kind of like explore that in depth and see how deep that resonance goes for me. Like if that really is something that like, I feel like that's the explanation for the behavior I'm seeing.
Sorry, Marianne, you locked up completely then, so I don't know quite what happened. Anyway, we'll sort that out online. So thank you for that. I think that was I think it's a conversation that could carry on and on. So
yeah,
hopefully people will reach out and continue that activity. No questions online, so I think probably the sensible thing is to thank you again for giving your time. Much appreciated. And certainly encourage more people to actually catch up on this, to get a different perspective on modernisation rather than purely just that sort of technical view of what they're trying to do, and approaching it as an opportunity for technical challenge and to do something new rather than actually understanding what problem they're trying to fix. So thank you again for your time. Encourage other people to feedback on the session. I'm sure you'd appreciate that. And with that, we will close it out. Thank you again, Marianne.
Thank you.